Hello everyone. I had a request from someone to do a question from this question paper. It's a grade 11 physical sciences question paper. It was written in November 2017, right? So I took this question paper from this app. If you go into your Google Play Store, you actually will find this question. Just type grade 11 exam papers and you'll find this app, and it has a number of question papers, previous question papers. So the question that the person was interested in was question 1.10. It's this question over here, and it's a multiple choice question. So even when you're sitting in an exam, you should not be spending too much time on this question. But in this video, I'm going to be as slow as possible so that you understand. So it's question 1.10, right? It says in the circuit diagram below, the battery has a negligible internal resistance. So for now, we don't need to consider internal resistance, right? And then the resistance of the ammeter and wires may also be ignored. So you should not be worrying too much about the resistance of the wires, right? And now they are asking us to say, what will the reading on voltmeter V3, the reading on voltmeter V3 will be equal to, and you are given a number of options with A, B, C, and D, right? So how do we begin? How do we start answering that question? This question, I found it to be very interesting because it actually requires you to understand those laws about resistors that are in parallel and resistors that are in series. It includes both. So, okay, so you know this will be your battery, right? So that's the sign of a battery. And this part here will be the positive terminal of your battery, and this one will be the negative terminal of your battery. And using conventional current, you know that your current, I'm seated in a very noisy environment. I hope you can still hear me. So your current will move from the positive terminal all the way through this entire circuit up until here in the negative terminal, right? So let's track the direction of the current. So the first thing for you to determine which resistors are parallel, which resistors are in series, first track your current. So you see, okay, my current will go down there. Now when it reaches this point over here, you see now it's gonna split, because now we have two branches. You have this branch over here and you also have this branch. So it means that a certain current will go through here, this branch, to this resistor, and a different current will go through this branch through the first this resistor of 8 ohms, and then it will continue again, and finally the same current that went through 8 will go through this one 8 ohm resistor again. So what is that telling me? Because the current here splits, it means that this branch that contains the resistor, the 4 ohm resistor, is parallel to this branch that contains both the 8 ohm and the 8 ohm resistor. So the 4 ohm resistor is parallel to these two resistors over here. However, these two resistors here, this one and this one, are in series to each other. So now let us remember the laws. So if we have parallel resistors, so resistors that are in parallel, we're just going to write P for parallel. What do we know about them? Is that they split the current. So they split the current. Resistors in parallel will split the current. Hence I said that the current will come here. Let's say it's the total current. We call that IT, right? But then when it gets to this point, we'll have maybe I1, and then maybe the current that will split, the current that will come to this branch will be I2. So your IT will be equals to I1 plus I2. So that's one thing about resistors in parallel, right? However, they split the current, so let me write split I. However, the voltage between parallel resistors is the same. So it means the voltage in this branch that contains the 4 ohm resistor and the voltage in this branch that contains both the 8 ohm and the 8 ohm resistor will be the same. So we will know that the voltage in this branch here, this branch, let me change the color. Yes, this is red. So in this branch here, let's call that voltage V1. So you will have V1, right? So that's the voltage in that branch. And now this voltage will be equal to the voltage in the branch that contains both these resistors that are in series. But now it gets tricky. We know that because these 2 resistors are in series, they will have the same current. So let's say the current that was going through this branch, we called it I2. So I'm just going to write I2, as well as the current in this resistor will also be I2, right? They will have the same current because they are in series to each other. However, they will split the voltage. So it means that they will split that total voltage. So the voltage that comes in this branch, I said it's V1. It means also the voltage that will come here, it also in this branch, the total of it will be V1 because it will be the same amount of voltage. So it means that even in this branch you also have V1. However, these 2 resistors will split that total voltage of V1, meaning now you're going to have an equation such as this one, where you have V1 will be equal to V2 plus V3, right? So it means, what this means is that the voltage that comes in this branch is V1. However, these 2 resistors that are in series with each other, they split that total voltage of V1 that came through that branch. However, if you look carefully at this resistor here and this resistor here, they are the same size. And we also know that the current through that resistor is also the same size. So what does that mean? It means that essentially it means that the voltage on this resistor of 8 ohm, which is V3, will be equal to the voltage on resistor, the other resistor, which we call V2, right? So if they are the same, I can just take this and substitute. So in the place of V2, I can just write V3. Then you're like, okay, let me write V3 over there. So you have V3 plus V3. So then you have V1 on this side, right? But now you see, okay, this is a bit of math. V3 plus V3 means I have 2 V3s. And then on the other side, you still have V1. And I want to see how much, in relation to V1, how much is V3. It means I now divide both sides by 2. Divide by 2. And if you do that, 2 divided by 2 will just be 1. So on the other side, you'll be left with V3. And then here, it's just going to be a half of V1. So then you go, okay, you look at your options, which one resembles this. So the voltage on V3, according to me, will be a half of V1, and we see the answer is going to be B. I hope that is clear. I hope I really explained that in a way that it is understandable. So let me try to explain it again, just summarizing. You have a voltage, so you have a voltage that comes through these 2 branches. You have this branch here, the red line, and then this branch here again. This branch only contains 1 resistor. This branch contains 2 resistors that are in series. So we know this branch is parallel to this branch. So that means that the 4 ohm resistor is parallel to both these 2 resistors, which are in turn series to each other. That means that resistors that are in parallel, they will have the same voltage. So it means that we will have V1 in this branch, but we will also have V1. The total for this in this branch will also be V1. However, that V1 will be split into 2 because these 2 resistors now are in series, and we know that resistors that are in series, they split the voltage. So for example, if you had a voltage here of 4V, so let's say V1 was 4V, so that was the value of V1, it was 4 volts. And then it means that a voltage of 4V will also be going through this entire branch, right? However, that voltage will be split. It's split into half because both these 2 resistors are equal and they have the same current through them. It means that V2 and V1 is the same. So they have to share 4V equally. This means that this resistor will have a voltage of 2V, and this one will also have a voltage of 2V. If this has a voltage of 2V, 2V is just half of that 4V, right? So meaning the voltage on V3 will always be a half of the voltage that we found here on V1. Hope that is clear. Thank you so much for watching.